Hello everyone, welcome to my YouTube channel. Today we are going to discuss Poisson distribution. This distribution can be derived as a limiting case of binomial distribution. This is the limiting case of binomial distribution by making n very large and p very small. That is most important thing for Poisson distribution. When it is given n is large and the probability is very small, then we use the Poisson distribution keeping np fixed, where np equals to m. So probability at r, that is equals to e raised to power minus m raised to power r by r factorial. This is the formula for Poisson distribution. Next is constants of Poisson distribution. Mean, that is np equals to m. Standard deviation, that is equals to root m. That means that is equals to root np. Skewness, that is 1 by m. Kurtosis, that is 3 plus 1 by m. Next is applications of Poisson distribution, where we use the Poisson distribution. First, arrival pattern of defective vehicles. Here it is given for defective vehicles in a given pattern in a workshop, patients in a hospital, or telephone calls. Number 2, demand patterns for certain spare parts. And number 3, number of fragments from a shell hitting a target. Where in the statement this type of patterns are given, then we use Poisson distribution. And this is important. In Poisson distribution, mean equals to variance. Next, how we use Poisson distribution. If the probability of a bad reaction from a certain injection is 0.001, that means this is given our probability. Determine the chance that out of 2000 individuals, that means it is given our number n individuals more than 2. So we find the probability for more than 2 will get a bad reaction. So here probability is very small and n is very large. So we use the Poisson distribution. So mean, that is m equals to np. So n is 2000 and probability is 0.001. So that is equals to 2. So we find probability that more than 2 will get a bad reaction. More than 2, that means it contains 2, 3, 4 up to so on. So we find 1 minus probability that no one gets a bad reaction. That means probability at 0 plus probability that gets 1 bad reaction. That means we here find probability at 1 plus probability that 2 bad reactions. So here we find the probability for 2. So it becomes 1 minus probability for 0, e raised to power minus m raised to power 0 by 0 factorial, plus probability at 1 is e raised to power minus m raised to power 1 by 1 factorial, plus e raised to power minus m square by 2 factorial. It becomes 1 minus 1 by e square plus 2 by e square plus 2 by e square. Here we substitute our value 2 for m. And it becomes 1 minus 5 by e square. And here we substitute the value of e 2. So it becomes 0.32. So in this way we can apply Poisson distribution. Next is one more question. If x and y are independent, Poisson variates such that it is given probability at x equals to 1 equals to probability at x equals to 2. This is given our first condition, and number 2, probability at y equals to 2 equals to probability at y equals to 3, and this is our second condition. Find the variance of x minus 2y. So here we let x variate is probability at lambda and y is probability at mu. So then probability at x, that is equals to e raised to power minus lambda, lambda raised to power x by x factorial, where x goes from 0 to infinite and lambda is greater than 0, and probability at y, e raised to power minus mu into mu raised to power y by y factorial, and y is from 0 to 1 and also mu is greater than 0. Since it is given in the statement that probability at x equals to 1 equals to probability at x equals to 2, and second condition is probability at y equals to 2 equals to probability at y equals to 3. It becomes lambda e raised to power minus lambda equals to probability at x equals to 2 is lambda square e raised to power minus lambda by 2 factorial. Here for y, mu square e raised to power minus mu by 2 factorial equals to probability at y equals to 3 mu cube into e raised to power minus mu by 3 factorial. By solving we get this value common and into lambda minus 2 equals to 0, and second equation becomes mu square e raised to power minus mu minus 3 equals to 0, and here we get the value of lambda is 2 and value of mu is 3, since lambda and mu are greater than 0. So now variance of x, we know that variance and mean are equal in Poisson distribution. So that means variance of x is also 2 and variance of y is 3. Now variance of x minus 2y, that is equals to 1 square into variance of x plus minus 2 square into variance of y. Here we use this formula, variance of ax plus by equals to a square into variance of x plus b square into variance of y. So 1 square is 1, variance of x is 2, so we substitute here, plus minus 2 square is 4 into variance of y is 3. So by solving this we get variance is 14. So variance of x minus 2y equals to 14. So in this way we can apply Poisson distribution. Thank you so much. Hope you all understand. If you have any doubt, please write in comment section. Thank you.